Okay, so you can see that on the right I have our formula booklet open, and we're going to make sure that we look at this because you're always going to have it for exams, so get used to using it. All right, I'm asked to differentiate y equals x squared secant x, so that's product rule. dy dx is 2x secant x plus x squared. I don't have derivative of secant x memorized. I'm going to look it up, and it's secant x tan x. I always like to have a factored answer, so I'm going to take out the x secant x and have 2 plus x tan x left over. I've got quotient rule for this one. Remember, quotient rule is also in your formula booklet, so I could scroll down if I wanted to see my quotient rule down here. Basically, I've got derivative of top times the bottom minus top times derivative of the bottom over bottom squared. I'm going to slide this back over a bit for myself. And we don't want the integral page. All right. So, derivative of top, that's going to be 0 plus derivative of tan is secant squared times the bottom, that's going to give me secant cubed, minus derivative of the bottom, secant x tan x times 1 plus tan x. Oh, goodness. All right, 1 plus tan x over bottom squared. So I'm going to simplify. All of these have a common term of secant, so I can cancel that out. So dy dx is secant squared x minus tan x times 1 plus tan x all over secant of x. Secant squared, well, I seem to remember that that is a trig identity. Going the wrong way. So with my trig identities here, I can see that secant squared definitely is something. Secant squared is 1 plus tan squared, so I'm going to expand and see what happens. So 1 plus tan squared minus tan minus tan squared. So I can see that those are going to cancel all over my secant x. So cancel out the tan squareds. I'm going to have 1 minus tan x over secant x. Notice that's a really interesting derivative that happens, that the derivative of this turns into 1 minus tan over secant. Awesome. All right. We've got some chain rule here. So dy dx is going to be 1 over 2 root cosecant 3x times derivative of the inside. Again, that's chain rule. So derivative of cosecant, now I need to go back down here. So derivative of cosecant is going to be negative cosecant cotangent. So I'm just going to go ahead and put it on the top. Negative cosecant, I'm going to have cosecant of the 3x, tan 3x times derivative of the inside. Derivative of 3x, of course, is just 3. So I'm going to put that 3 out here. Now I could simplify this. Cosecant 3x divided by root cosecant 3x. That's going to be the same as negative 3 halves root cosecant 3x tan 3x. Okay, secant squared minus tan squared. Well, we saw that secant squared is 1 plus tan squared minus tan squared. Well, that just simplifies down to being 1. So then the derivative, of course, is just 0. Notice that what we're saying is that this function, if we graphed it, would really just become a straight or a horizontal line. So that's also a nice little thing to think about in terms of the derivative. All right, now we're combining exponents and our inverse or reciprocal trig functions. So using product rule, derivative of this is going to be 3e to the 3x cosecant x plus e to the 3x, and now derivative of cosecant was negative cosecant cotangent. So I will factor. So e to the 3x cosecant of x, that's going to give me 3 minus cotan of x. Again, I've got a chain rule. So derivative of ln is 1 over, and then derivative of cotangent is negative cosecant squared. So I'll put that on top. And we could simplify this using our trig identities, or we could just leave it like this.